Welcome back to week 3, and in video 3 we are going to explore some of the sedimentary rock environments and how you distinguish the history of a sedimentary rock. So basically what are we going to do? Well, what are the major depositional environments? How do you tell what rocks are deposited where? What does the texture of a sedimentary rock tell you about its past, where it's been, what it's been through, basically. And then if there's any other structures that can help determine the history of a sedimentary rock. So there's lots of different depositional environments. The major ones we're going to talk about in this class include glaciers, rivers, beaches, deserts, lakes, deep ocean, bay, harbor, estuary, and then reef or shallow sea. And here's just an image to kind of show you kind of what those things look like if you're not sure. So glaciers, we've got glacial action eroding material and depositing material. We usually get breccias or conglomerates in these environments, so more angular particles, maybe somewhat rounded, but usually pretty angular because that stuff is not traveled very far. The further you go, the more rounded the particles are going to get. If you move to rivers, this is where we have the particles able to actually tumble around against each other, roll around, and we get more rounded grains. Faster the stream is moving, the larger the particle it can carry. So faster moving streams, like the two that you can see down here, would have more of the conglomerate sized particles, and then slower moving streams, you're going to have more sandstone or mudstones or shales that can be deposited. A Mississippi River would be a good example of one that has a lot of clay particles in it. Beaches, this is where we get lots of sandstones. So sandstones can be made of quartz and calcite, or both, or one or the other. And some of those sandstones can also be made of rock fragments, but usually you're going to have more quartz deposited. If you have calcite or shells present, that means you have a lot of biologic activity offshore. So lots of reefs that could be present. So places like Florida beaches, a lot of those beaches have more calcite present because there's reefs just offshore. Whereas around here, we have more of the quartz, rock fragment type stuff because we don't have as many reefs present. And if there are tide pools nearby, you might have some biologic sediments present. Desert environments, we can also get sandstones here with quartz, rock salts, arkose. So in desert environments, the thing to remember is that there isn't a lot of water present, so hydrolysis doesn't happen as readily, so we can still see minerals like feldspars. Feldspars are pretty easy to break down through hydrolysis, and we get sandstones that might have a reddish color because we may have oxygen present, and that oxygen is going to be oxidizing any iron that might be in that rock. So if that sediment is exposed to air, that means we've got oxidation that can happen. So when we see a red sample, it's a good indicator that you've got a rock that came from the desert. And so here you can see some sand dunes that have been deposited here in Death Valley, and then here is one of these big wide flat basins that in the wet seasons can fill with some salty water, and then in the dry seasons that water evaporates and leaves the salts behind, like you can see here in this sample in my hand. So places where we can get things like mudstones and shales would be calm water, like lakes, the deep ocean, estuaries, bays, anywhere where the water is still enough where those clay particles can actually settle out. And these clay particles have a similar shape as like the micas that we looked at in week 1. So as the water calms down, the clays settle out like maybe a feather floating down to the ground, or if you drop a piece of paper, it's the similar kind of thing. So you need pretty calm water for those to be deposited. We can also, in swampy environments where there's lots of organic matter, we can get coal forming, where we've got that organic matter buried pretty quickly so that it doesn't break down. That carbon gets trapped, and then it eventually, over time, as it compacts and solidifies, it will turn into coal. And then in lakes we can get some types of chalk. Deep ocean we get chalk or chert. forming in the deep ocean as well, and both of those are forming as the chert forms because the silica is precipitating out of water. Chalk is actually microscopic little critters that die and sink to the bottom over time, and all of these are going to be places where we have pretty calm water. And then a reef or shallow sea, where we have a lot of biologic activity, we get lots of limestones or sandstones. And if we've got a limestone or we've got a reef shallow sea environment, you're going to see fossils. And here's just 4 examples of different rocks that you can see shell fragments in each of these different rocks. So those are the major environments you're going to be fitting these rocks we see in lab into. So what does the grain size, shape tell you about the history of those sediments? Well, basically, if we start out where that sediment has been eroded from or weathered from, those particles are going to be pretty angular. And this is going to be for detrital or biologic materials. The chemical, that stuff gets dissolved in water, doesn't really apply here. So these detrital or biologic materials, we have angular particles pretty close to the source. They haven't had a chance to break down and get rounded through transportation. As we move further away from the source, like down into the plains or river type situation, those grains have had a chance to be tumbled against each other. They get more and more rounded over time. And some of the rock fragments, so the rock fragments and minerals are kind of these orange, reddish colored and tan colored sediments. The yellows are going to be more quartz minerals. The weaker particles, the ones that are more susceptible to hydrolysis and chemical weathering, are going to keep breaking down. We're going to get less and less of those and more quartz. By the time we get out to the beach, if we have a beach that's filled with quartz sand and not a lot of other stuff, that's a sign that those sediments have traveled pretty far. And if they're nice and rounded, that's another sign that, hey, these sediments have traveled a long ways to get to this location. So if you're at a beach, you're at a river, and you've got pretty rounded particles, it's a sign that's been transported pretty far. The more quartz you have, the longer that sediment has been transported, the further it's gone to get to that spot. Quartz is pretty hard, pretty resistant to erosion, so it sticks around quite a bit. So some other structures that can help determine the history of a sedimentary rock, well, we have a couple different things here, and these are all actually in the same location in Glacier National Park. We see this image here, we can see these kind of wavy ripples on the surface of this rock. These are ripple marks. They form in pretty calm water where the wind or maybe there's a slight current in the water moving the water back and forth to form those ripples. And actually this rock alternates from these ripples to these mud cracks and then to these raindrop impressions. So what happened in this environment, it was alternating wet and dry. Mud cracks, basically the clays that are deposited, when they dry out, they shrink and they form these crack patterns, and once they get wet again, they expand and those cracks go away. So throughout time here, this environment was going through wet periods, dry periods, and then when you get these raindrop impressions that are actually freezing in time when that rain event happened, which is pretty cool. And then this last one here, this sedimentary rock started to solidify, and then there was some kind of earthquake that happened that caused that stuff to jumble up before it solidified, and then we get these small bits and pieces of some of the material all jumbled up and disorganized. So these are some of these sedimentary structures are a way of kind of looking at a rock and saying, well, what happened in the history of this sediment? And your book goes into some more detail into some of the other sedimentary structures. So that kind of wraps up sedimentary rocks. We'll come back in the next 2 videos and talk about metamorphic rocks.